Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, or good night to all of you whenever you watch this video. We are from group 7. In this video, we'll talk about the liquid and gaseous substances. For the English for Science and Technology. So we have the 4 unit in this video. This is our contents. We have the 4 units. That is unit 1, liquid and substances, will present by Saskia Maharani Putri, and unit 2, that is conversion, will explain by Siska Saputri, me, and unit 3, the water, will explain by Rosa Medina, and unit 4, that is gas, will explain by Saskia and Rosa. So in the last part, I will give you the conclusion. So we move to the unit 1, liquid substances, will explain by Saskia Maharani Putri. To Saskia, screens is yours.
Okay, thank you, moderator. Okay, everyone, I will talk about the unit 1. In the unit 1, we will talk about introduction, liquid substances, explain crude oil, and vocabulary building. So the first one is introduction, liquid substances. Liquid substances are materials that can flow and take the shape of their container, like water or oil. They have a defined volume and hard to compress. Liquids stay together due to forces between their particles, and they can boil into a gas or freeze into a solid at specific temperatures. Liquids also have surface tensions, which makes them from dark plates and behave in certain ways. So we move to crude oil. The crude petroleum oil obtained from wells consists of a mixture of hydrocarbons, each of which is a chemical compound of carbon and hydrogen. The simple hydrocarbons are gases. The simplest of all is the gas methane, the molecule of which has 1 carbon atom and 4 hydrogen atoms. Methane has a boiling point 160 Celsius. Hydrocarbons with from 5 to 18 carbon atoms are liquid at normal pressure and temperatures. For example, octanes found in its gasoline have 8 carbon atoms and boil between 106.5 Celsius and 125.8 degrees Celsius, depending on the structure of the particular octane. Hydrocarbons with larger molecules have higher melting and boiling points than hydrocarbons with smaller molecules. The hydrocarbons with larger molecules, such as found in the paraffin wax, are normally solid or semi-solid at normal pressure and temperature. The heaviest molecules of all, with more than 50 carbon atoms, are found in bitumen. Thus, the hydrocarbons in crude oil range from dissolved gases and light liquids to heavy oils and waxy solids. The proportion of the various hydrocarbons differ from one oil field to another, and the properties of each deposit of crude oil have to be determined and evaluated. Crude oil may also contain some impurities such as sulfur. So we move to vocabulary building. It's talking about the previous slide. The first one is hydrocarbons. Hydrocarbons are the primary constituents of fossil fuels such as gasoline, diesel, and natural gas. They are also found in many other organic compounds and play a crucial role in organic chemistry and the petrochemical industry. The second one is compound. In a chemistry, a compound is a substances formed when 2 or more different elements chemically combine in fixed proportions. Compounds are distinct from mixtures, where elements and/or compounds are physically mixed together but do not undergo a chemical reaction to form new substances. Example of compounds include water or H2O, composed of 2 hydrogen atoms and 1 oxygen atom, and sodium chloride, NaCl, composed of one sodium atom and one chlorine atom. In contrast, mixture like air or a solid contain in combinations or elements and compounds that are physically mixed together but do not chemically combine to form new substances. Next is methane. Methane is a colorless, odorless, and highly flammable hydrocarbon gas with the chemical formula CH4. It is a primary component of natural gas, and is released during the decompositions of organic matter as well as in the various industrial processes. Methane is a potent greenhouse gas and plays a significant role in the climate changes when released into the atmosphere, as it traps heat more effectively than carbon dioxide over the short term. So next is octane. Octane is a hydrocarbon composed with the chemical formula. It's CH18. It is a key component of gasoline, where it helps determine of the fuel anti-knock properties, specifically its octane rating. Octane rating measures a fuel resistance to engine knocking, a damaging and inefficient form of combustions. High-octane fuels are less prone to knocking and are used in high-performance and high-compression engines to improve engine efficiency and reduce the risk of engine damage. The next one is paraffin wax. Paraffin wax is soft, white, solid derived from petroleum, composed mainly of long-chain hydrocarbons. It has different uses from candles to food packaging due to its low melting point and protective qualities. The next one is bitumen. Bitumen is a thick, black, and sticky hydrocarbon substances derived from crude oil. It is used in various applications, including road construction, roofing, waterproofing, and as an adhesive. The last is sulfur. Sulfur is a chemical element as known for its yellow color. It has many uses, including the production of sulfuric acid, fertilizer, and rubber vulcanization. It's also essential for living organisms as a component of amino acid. Okay, everyone, maybe that's all from me. Back to the moderator.
Thank you very much to Saskia Maharini Putri that already explained the unit one, that is liquid substances, and Saskia already talked to you the crude oil that obtained from wells consists of the mixture of hydrocarbons, each of which is a chemical compound or carbon and hydrogen. And Saskia already talked to you the vocabulary building like hydrocarbons, compound, methane, octane, paraffin wax, bitumen, and sulfur. So we move to the unit 2, that is conversion. I will talk to you. The first is introduction, conversion, and conversion text. The last is vocabulary building. So in the scientific context or in the science, conversion typically refers to the process of changing one form of energy, substance, or unit into another. This transformation can take various forms, such as converting chemical energy into the thermal energy, converting units of measurement, or changing one type of molecule into the another through a chemical reaction. Conversion are fundamental in scientific experiments and equations, allowing scientists to analyze and understand the relationship between different variables and phenomena. So I will show you about the conversion. In some countries, gasoline for petrol is the most important fraction, whereas in other countries, fuel oil. For heating and for heavy industry may also be important. Heavy fractions are converted into lighter fractions in a catalytic cracking unit. Inside the reactor, the large molecules are then separated in a distillation column, which is a part of catalytic cracking unit. Catalytic cracking yields gas, high-grade gasoline, and diesel fuel. The quality of some of this gasoline is now improved by using platinum as a catalyst and a reaction which takes place under controlled conditions in a special unit called a platform. The conversion process improves the low-grade gasoline by reforming its molecules. Reformed gasoline is generally blended with the desired proportions of low-grade gasoline and high-grade gasoline obtained by catalytic cracking. The main products or crude oil may be given further treatment before the refinery. We can see the picture about the conversion like in your screen. Okay, move to the vocabulary building about the conversion. The first one is accelerates. What is the accelerates? That is a scientific progress and discoveries are happening at the faster and um, increasing rate. It indicates a swift pace of advancement in various scientific fields. Accelerates refer to the increasing speed at which scientific discoveries, advancements, and innovations are being made. This acceleration can be observed in various scientific disciplines and is driven by a range of factors. And the next is distillation. What is the distillation? Distillation is a separation process used to separate components of a liquid mixture based on their differing boiling points. And the condensed liquid known as a distillate is collected separately. This process is commonly used in chemistry and various industries to purify liquids, separate components, or obtain specific substances from a mixture. And the last one is a and the next is treatment. Treatment typically refers to a specific procedure or interface applied to a subject, sample, or system as part of an experiment or study. That is the treatment. Treatment can vary widely depending on the field, science, and objectives of the study, and they are often used to test hypotheses. For example, evaluate the efficacy of a drug or procedure, for example, or understanding the impact of the certain factor on the system. And the next is purified. That is the process of removing impurities or unweighed substances from a sample, compound substances or material to make it clean, more concentrate or more suitable for a specific. Common purification technique include filtration, distillation, and chromatograph crystallization and something like that. So we move to the applications. What is the applications? The practical uses or implementation of the scientific knowledge and discoveries in various fields. These are the ways in which scientific principles, theories, and the technologies are put to work to solve real-world problems. For example, advanced technology, improve process, or achieve specific goals. Scientific application can vary widely depending on the discipline, but they often involve using scientific understanding to design and develop solutions or products. Next is manufacture. What is the manufacture? That is the process of producing goods or materials, often involving the application of scientific principles and technological process. Manufacture it typically involves turning raw materials or components into finished products through a series of systematic and controlled steps. In this context, the term emphasizes the application of scientific knowledge and engineering expertise to design, for example, develop and optimize manufacturing process, ensuring the quality, consistency, and the efficiency and products. That is the manufacture. The last one is insecticides. What is the insecticides? Insecticides are chemical substances or compounds that are specifically designed and used to control, repel, or eliminate insects. For the example of the insecticides you can see in the screen and the picture. Insecticides are a subset of pesticides pesticide, which are chemical agents used to manage or eradicate various pests, including insect, weeds, and plant disease. So that's the about conversion. I already talked to you. I already talked to you what is the conversion and vocabulary building about the conversion. So we move to the unit 3. Will explain to you by Rosa Medina. To Rosa Medina, screen is yours.
All right, so we move to the unit 3 about water. What is water? Water is the only common substances to exist as a solid, liquid, and gas in normal terrestrial conditions. Water is the liquid phase of H2O. Okay, there is a text about water. Water, whose semi-cell formula H2O, is one of the most precious resources we have. Without water, we could not be able to survive very long, because the danger of industrial pollution of water is also real today. There are attempts to recycle it by means of modern technology. The following passage is an example of such an attempt. As population increases, the industry grows, so thus the demand for fresh water. The problem is that the supply of fresh water is limited, and much of what is available becomes more contaminated with pesticides of other pollutants as the land becomes more crowded. Recycling used water is one solution of this problem, but many water treatment methods are either too costly or unsatisfactory. As an effort to make better use of this essential resource, some American companies are developing new water recycling methods which produce absolutely pure water at economical rates. One such method was developed by scientists from the Florida Institute of Technology for treating impure water and even sewage with radioactive cobalt. Gamma rays kill all harmful bacteria, virus, and detergents harmful for the water while avoiding any radioactive contamination. The water is then filtered and scrubbed clean of all particles. The result, said Dr. David Woodbridge, a physicist and co-inventor of the method, is clear, pure water fit to drink. We next to the vocabulary building from the text of water. There are survive. Survive is to continue living or existing, especially under adverse or challenging conditions. And next is pollution and pollutants. Pollution is introduction of harmful substances or contaminants into the natural environment, causing adverse effect on the ecosystem, living organism, and human health. And pollutant is the specific substances or agents that cause pollution, such as chemical emissions or water waste product. Next is recycle. Recycle is the process of collecting and processing material that have been used and discarded to create new products, thereby reducing waste and conserving resources. The next is pesticides is chemical substances used to control or eliminate pests such as insects, rodents, or weeds in agriculture and other settings. And resource is a source of supply of something that can be used to meet a particular need. Resource can be natural, human-made, or intellectual. Next is contamination. Contamination is the presence or introduction of harmful or undesirable substances into an environment or a material, making it impure or unsafe. Filtered. Filtered is reversed to the process of passing a substance or material through a filter to remove impurities, particles, or unwanted components. And then scrubbed. Scrub is the past tense of scrub, which means to clean or purify something by scrubbing, rubbing, or washing it thoroughly. And the last one is raise. Rays is a beam of light or energy that radiates out from a central point. It can also refer to various types of radiation, such as X-rays or gamma rays. All right, that's all for me. Back to the moderator.
Okay, thank you very much for Rosa Medina that explained Unit 3. So Rosa already talked to you about the water. Water is familiar to us, right? But in science context, what is water? What's about water? Rosa already talked to you, like for example, Dr. David Woodbridge said. Rosa already talked to you the vocabulary building about the water, like survive, pollution, recycle, pesticides, and something like that. So we move to the unit 4, that is the gas. Gas, I will explain the first by Saskia Maharani Putri. To Saskia, screen is yours.
Okay, thank you to moderator. So we talk about the gas in the unit 4. So we move to the next slide. We have seen that in the case of real gas, only in the limit as the pressure approaches zero does the equations of state assume that simple from a PV equal nRO. Furthermore, the internal energy of a real gas is a function of pressure as well as of temperature. It is convenient for a gas expert to define an ideal gas whose properties, while not corresponding to those of any existing gas, are approximately those of a real gas at low pressure, whether as actual gas may be treated as ideal gas depends upon the error that may be tolerated in a given calculation. An actual gas is at a pressures below about 2 atmosphere may be treated as an ideal gas without introducing an error than a few percent. Even in the case of saturated vapor in equilibrium with its liquid, the legal gas equations at said may be used with only a small error if the vapor pressure is low. From a molecular point of view, it can be shown that the properties of an ideal gas are possessed by an assembly of large number of molecules, among which there are in attractive or repulsive forces. Back to the moderator.
Okay, thank you to Saskia that explained about gas. We move to the vocabulary building that explained by Rosa Medina. Rosa, screen is yours.
All right, so I want to talk about vocabulary building from the text before. The first one is equation. Equation is a statement that two expressions are equal. Typically containing one or more variables, equations are used in mathematics to express relation between different quantities. And then saturated is when a substance has absorbs as much of another substances as it can hold. In chemistry, if it often refers to a solution where no more of a solute can be dissolved in a solvent. The next is convenient. Convenient is something that is easy to use or access, making tasks or activities more straightforward or efficient. And the last one is tolerated. Tolerated is means to allow or endure something, even if it's unpleasant or disagreeable, without reacting negatively. That's all from me. Back to moderator.
Thank you to Rosa Medina that explained about vocabulary building from the gas. So that is the last topic of this video, that is gas. And Rosa and Saskia already talked to you what is gas, that is a process by assembly, for example, and vocabulary for the gas like equation, saturated, convenient, and tolerate. So by the end of the topic from the gas, that is the last for this video, and the group 7 already talked to you about the liquid substances like crude oil, conversion, water, and gas. That is the topic from liquid and gaseous substances. So that's all for the group 7. Thank you very much, and sorry for the any mistakes of this video. Assalamualaikum warahmatullahi wabarakatuh.